Today we're going to be talking about lesson 9-2, which is about translations. So we're going to perform translations on and off the coordinate plane and then talk about some predictions. So open up to page 108 and we're going to go ahead and get started here. Okay, so Maria marches with the band. At the start of the halftime show, her position is at 2,4. So I went ahead and marked that on the graph here. Here's 2,4. So there's her start position in red. Then Mr. Scott tells everyone to move 2 yards to the right on the field and 4 yards up. So that is the new position for Maria in blue there. Okay. So we're going to use this to kind of answer the next couple questions. But before we do that, we're going to talk some vocab. So this type of transformation is called a translation. So that is a rigid motion in which every point is moved the same distance in the same direction. Okay, so not just Maria is not going to move 4 to the right and up 4. Everybody in the band, so you see how this entire rectangle all shifts in that same direction. So that is a translation. And remember, rigid motion means it preserves the size and the shape. Okay, so on the coordinate plane, a translation is described by the function like this. So we would say x comma y. Your arrow, remember from our last lesson, just means goes to. Okay. So that goes to, we would say like x plus or y plus. Now that's if something goes right or up. If we had something going left, okay, or down, we would say like x minus a, x minus a, comma y minus b. So if anything goes left or down, we would use minuses because we're going in the negative direction. But okay, during a translation, every point on the figure moves the same distance and in the same direction. And that direction is called the directed line segment. Okay, that's the distance and direction of the translation. That just tells you kind of which direction and how far you're moving. So let's look at this table here. So complete the table to show the translation effect for the 4 marching Cougars. So remember, the band director had them move 2 yards to the right. So we're going 2 right. And then 4 yards up. So go ahead and fill in this table. So Maria's new spot, if she went 2 to the right, would be at 4. And then up 4 would be at 8. So they showed us that X on the graph. But go ahead and fill that in for the rest of the people. Joe, Alfredo, and Lejea, I guess we'll say. So now Lejea, though, they gave you the image, and they want the coordinates for the pre-image. So just be careful on that one. So go ahead and fill in that table. Take a second there. Okay, so your table should end up looking like this guy here with our pre-image and our post-image. So every point should be moving the same direction and the same distance. That's what a translation is. Everything moves together, okay, on that coordinate plane. So now let's look at the next page where we have that Mr. Scott arranged the band in a rectangle. Then he directs the band members at 6, 10. So again, let's kind of mark that. At 6, 10. He directs them to move to 4, 13. So 4, 13. Okay. The number on the coordinate plane shows the yards on the football field. So we're going to, in number 2, talk about what's for the band to move this translation, how should each band member move? So how do we go from the red point to the blue point? Or you could even look at it in terms of the numbers. How do we go from 6 to 4 and 10 to 13? What are we doing there with each coordinate? Okay. Well, hopefully you read that as we're going left 2, and then we're also going to go up 3. So this point here, it's going left 2 and up 3. That's how we get to that 4, 13. So if we had to write that as a function, I don't know if your book asked us to do that or not, but I figured why not. If we have x, y, and we're saying it shifts left 2 and up 3, how would you write that as a function? Remember, the function is using like the x plus or minus the number and y plus or minus the number. So go ahead and think about that for a second. Okay, so here's what we have. So if we went left 3, that means we're moving in the negative direction. So our x value went minus 2. If we go up, that means our y value is increasing by 3. So we'd have y plus 3. So this is kind of the main point of this lesson, is being able to write these translations in terms of a function, okay? And remember, the translation, since it's rigid, will always preserve the length and the width. So it's always, everything has to shift together. Okay, let's just jump to this check your understanding here. So I'm going to have you guys try these problems. So draw the image of the figure under this translation described by the function. So we have a rectangle here. This is our pre-image. And they want you to translate it so that it becomes x plus 4 and y minus 4. And then in number 5, we're going to take this triangle and we're going to translate it to x plus 3 comma y. So take a second there and just kind of draw those images based off of the pre-image. Take a second and do that. Okay, so number 4, if we're taking x plus 4, that means we're going to the right 4. And y minus 4 means we're going to go down 4. So we're going right and down. So your image should have been, if I can click on it right there. So if we take that rectangle, oops, I made mine kind of too big, but no big deal. Pretend that's not there. We take our points and we shift it to the right and down. And each point, so each vertice of that rectangle has to do the same thing. Okay, now if we tried number 5, we should have been saying that the x plus 3 moves, we're going to the right 3, but that y doesn't change. So all we're doing is a kind of a horizontal translation. So your triangle, and mine's a little taller just because I couldn't get it to line up perfectly, but would look about there. Okay, so that's what a translation is. It's just a shift in the graph, so moving things left and right or up and down on that coordinate plane. Okay, on the next page, we're just going to kind of talk notation, but let's talk about translations can be defined without a coordinate plane. So if we don't have kind of an XY axis to look at, for the directed line segment, and I just went and stole the vocab from the other word. Remember, the directed line segment is the distance and direction of that translation. Okay, so they're going to show you some kind of notation here. So they're saying the directed line segment AB in a translation maps point P to P prime. So just so you guys know, P is the pre-image. Anytime we do a translation, we notate it with a little prime, a little kind of apostrophe. That means that's your image. So your second picture. Okay, so the beginning is P. P prime would be after you translate it. Okay. So how we can write this notation is right here. So how we read that is this is a translation, T, okay, of point P. So you're going to translate point P by the directed line segment AB. So AB is telling you how it moves and in what direction. So how long your translation is and what direction it moves in. And P is the thing you're actually translating or moving. So let's just kind of go over this with just one of these pictures here. So it says in image 6, we have a rhombus, which is a parallelogram with 4 congruent sides, and point P is in the center. So if we're doing a translation of point P along the line segment AB, this is how we would do it. So I already went ahead and made a kind of a matching rhombus. It's not going to be perfect, but it's going to be good enough. So if I put this rhombus, I'm just going to cover up the original picture. Okay. What that's saying is we're going to take our rhombus and we're going to translate point P, so that point in the center. I'll have it exactly right. Okay, and we're going to translate it along the segment AB. So that is the segment here. So AB right here. So this segment goes this way. So that's the direction it's moving, AB. And it has to be that same length. So this is the length of my line segment that I'm moving, I'm translating. And I'm also going in this positive direction towards AB, the way AB is kind of drawn. So if I do that with my rhombus here, it means I'm going to take this segment, move all this stuff, and I'm going to translate it, meaning just kind of move it, all the points move together in that direction, that length. So here's my point. Then we would call this point P prime. Okay, so that's what that means in that notation. So we're not going to do too many of these. We're going to mostly stick to what problems on the coordinate plane. But if it's written in this way, you have to know what it's saying. So it's saying translation. We're going to move point P along the segment AB. That's our, what they call the, I had a brain fart, the directed line segment. Sorry about that, brain fart. Okay, so the directed line segment tells you the length of your translation and then in what direction you're moving. So AB runs right here. So all I did was move it that same distance in that same direction. Okay, so I'm just going to have you guys answer the couple questions now on the check your understanding. So just number 10 here. So it says, Mr. Scott arranged the band in the shape of a triangle ABC, shown in the picture below. So we have P, that's our original image. And then we have P prime, P double prime, and P triple prime. So all these are different translations. So in A, it says, which of the three transformations are a translation? So which pictures here are just a shift in this graph, just a movement, left, right, up, or down? Well, hopefully you said it was just P and P triple prime, okay? P double prime, that is not a translation. This looks like the graph flipped. So we'll talk about what kind of transformation that is. But for right now, we don't know that as a translation. Translations are just a shift. So it'd be taking this triangle and just moving it somewhere else. So the position is kind of stay the same. Okay. All right. And then B says Maria stands at point P of triangle ABC. To move to point P prime, her instructions are to move 8 steps to the right. Do these instructions apply to all of the band members? So think of that. If her instruction is to move 8 units to the right and it's a translation, would that apply to all the band members or just Maria? Okay. It should apply to all of them. Okay, it can't just be Maria. Remember, in a translation, everything moves together. So all points are going to move the same direction and across that same directed line path. Okay, so if Maria moves 8 steps to the right, so does everybody else in the band. Okay, so the big takeaways from today's lesson is a translation is just a movement, okay, along the coordinate plane or along a picture, and just some kind of notation. P prime implies that that's your next image, okay, after you do the transformation. And just kind of knowing that notation here, how to read this if it's written in this kind of form.